Hey guys, it's Miss Burnett here. I'm just going over the notes that we're going to take on surface area in class tomorrow. Today's Thursday the 8th. Tomorrow is the 9th. We're going to do these notes in class. This video is just for anybody who needs to rewatch them or misses class or whatever, okay? So the learning target for today is that I can use the net of a 3D prism to find the surface area. And I'm going to go over all of that so it doesn't sound like it's written in another language. All right, I will go over what all those words mean and how to do it, okay? So we're going to start off with just defining what surface area means. All right, surface area is going to be the sum, and we know sum is a key word for addition of the areas of all the faces or sides of a solid shape or figure. We'll do it with shape. Okay, so when I think of surface area, I always think of like wrapping paper. Like if you have a present and you need to wrap it, surface area represents like the amount of wrapping paper that you would need. So think wrapping a gift, like all the cardboard of a box. So if you had a box and you completely unfolded it, all of that cardboard would represent like the surface area. Okay. To get us started, I'm going to draw a three-dimensional rectangular prism, and I want you to try to do it as well and just do your best. It doesn't need to be perfect. So I always like start with a box like that, and then from the corners, I draw little lines over like this, and then I connect the lines. Okay, and again, it's not perfect, and yours doesn't need to be perfect either. But just so we can kind of have some representation of a 3D shape, okay? So that's my rectangular prism, all right? You can see like the faces, all right? There's 1, 2, 3, 4, 5, 6. There's 6 faces on this, okay? The edges are right here, so like this would be an edge. And then these would be the faces, all right? The vertices or the corners are where the faces come together, okay, and meet. Now, this is the 3D version, okay, the 3D rectangular prism. We call it 3D because there's 3 dimensions, okay? There's a length, a width right here, and a height, okay? That's why we call it 3D. Now, when I use the word net, what I mean by net is like if you took the 3D shape and you unfolded it, okay? So I'm going to try to draw a net for this. Here is the bottom of my box. Here is the side of my box. Here's the other side of my box. Here is like the flap that goes up. A flap on the other side because I don't want a hole in my box. All right. So this is the bottom. This side comes up. This side comes up. This would come up, and then that would come up. I'm missing one thing though. If this was my rectangular prism net and I folded it up, it wouldn't have a top, right? So we need to add one more side that can represent the top. All right. So this is like the base or the bottom. We'll put bottom. This is one side. This is another side. Here's a side. And then here would be the top of the box, okay? So you kind of have to envision how it would be folded up, okay? Now, when I asked you to find surface area, I'm going to be asking you to find surface area of a nut, okay? I'm never going to give you something like this and tell you to find surface area. I'm always going to give you the nut, all right? And I'll ask you to find the surface area using the nut. So when you do that, you just find the area of every individual shape or individual part and then add them together, okay? We're going to write that down. I'm going to write SA for surface area. Find area of each part and then add together. It's a lot like a compound shape, and you guys have been doing really, really well with composite shapes and compound shapes. So that's why I feel like when I'm asking you to find the area of these three-dimensional shapes, you're going to do really well with it because you've done really well with compound shapes, okay? The only thing I want to do one more of, and I want to turn the page, okay, and just pause the video if you need to, is when you have a compound shape that looks like a pyramid, like this. Oh, I want to go back and do one more thing. I'm sorry, I meant to do that before. I want to make sure we recognize this is what I mean when I say nut. Okay, that's really important. When I say nut of a shape, I mean the shape that's been like folded flat. Okay, like I've taken a shape and I've cut all the edges and I've laid it all flat. Okay, geometry is very visual, and sometimes if you're not necessarily a visual learner or a visual person, sometimes this stuff can be hard. All right, but you kind of have to visualize what does she mean when she says that? Okay, so this would be the base. I'm gonna draw a triangle. Probably not gonna be perfect. That's okay. So sometimes you're gonna have three-dimensional shapes, and they're gonna have triangles in them. A triangular prism, a pyramid, a square pyramid, a triangular pyramid. All right, and you just need to know you're going to use the same strategy. Okay, so this would be the bottom, and then side one, side two, use the same strategy. Find the area of each section and add together. Okay. Sorry. Oh, this is side four. What was I thinking? All right. So this is actually going to be the net of a square pyramid. Just like the Pyramid of Giza that we looked at a few weeks ago, okay? So you find the area of each section and then add them together, okay? Okay, so we're going to do one example together of actually finding the surface area, because up to this point, we've just been talking about surface area. We've been talking about nets, talking about how to find the surface area, but I want to make sure we do an example, okay? So I think what I'm going to do, I'm going to try to do a triangular prism. I hope I'm using the right word there. So my vision here, it looks like this. It's going to have one side up, one side here, one side going down, and then it's going to have triangles on the side. So take a second to try to visualize what you think that would look like if it was folded up. Okay, because this is the net. Okay, try to envision if this is the bottom right here. All right, this would be the bottom. This side folds up and this side folds up, and then your edges are triangles. So finish drawing it and then try to envision what it would look like folded up. So when I'm thinking, like my vision that I kind of had looked like this, okay? That was what I was trying to go for. I was like, okay, I'm going to try to lay something flat that looks like this, where the sides are triangles and then the end, I guess the ends are triangles, and then all the sides are rectangles. Okay, so that's what I was trying to go for. And the name is triangular prism. Okay, so let's write that. Net of triangular prism. Okay, so in order to find the surface area, we're simply going to find the area of all the sides. Okay, I'm just going to label the sides. I'm not going to count the boxes. I'm just going to label them. We'll say this is 5 inches. This right here is, let's go with 2 inches. This is 2 inches. This is 2 inches. Now at this point, you're just treating it like a compound shape. You're finding the area of each section, and then you're adding your areas together, okay? I'm gonna pause this video because I wanna give you a second to work on it, okay? And I'll come back in a minute and you can see how you did. So I want you to pause and try to figure it out, and then we'll see how you did. Hey guys, hopefully you got it done. We should. Here is my work, so take a look, see if it matches what you have. I kind of divided it into the 3 rectangles. 5 times 2 is 10. Now the rectangles are congruent, or they're equal, all right? They're the same. So I went ahead and showed the math all the way down, but all of the rectangles should be 10 inches squared. Whenever you're doing area, you gotta put your inches squared. All right, and then I did my triangle formula, 2 times 2. The base right here is 2, and the height is 2. 2 times 2 divided by 2 is 4, and then 4 divided by 2 is 2. So each one of the triangles is 2 units, okay? I did the math on both sides. When I added all 3 together, I got 34 inches squared. All right, and just make a note, surface area is measured in inches squared. All right, because it is a measurement of area and how much space the 2D shape takes up, okay, when laid flat. We're going to keep practicing this for today, in class tomorrow, and next week, okay? So you're going to get quite a bit of practice with it, but feel free to watch it again if you need to, or just come and ask me questions whenever you have them. All right, you guys are awesome. I will see you soon.